Tonight's homework is going to be a lot of review, but there's one new topic, which is rationalizing the denominator. Perhaps you looked at this in geometry or algebra 1 or both, but essentially what rationalizing the denominator means is you want to get rid of the radical sign in the denominator. So if I see something like this, it's considered just proper math etiquette to get rid of the square root from the denominator. Back in the day, it was difficult to divide by a radical, and we just kind of follow that practice to this day of not leaving the radical sign in the bottom of a fraction. So what that looks like, quick review here, perhaps it's familiar. If I want to get rid of the square root of 11, that's what I would want to multiply by. And I can't just multiply the denominator, I should actually multiply the numerator also. This fraction equals 1. If I don't multiply the numerator as well as the denominator, I've changed the value of the fraction. So since I'm just multiplying by 1, I maintain the original value. Now what's that going to do? Well, in the numerator, I just have 2 square roots of 11. Make a note that, if I see this, I could say that's square root of 22. But right now, I just have 2 square roots of 11. In the denominator, square root of 11 times the square root of 11 is the square root of 121, which is just 11. Or you could think of it as 11 to the 1/2 times 11 to the 1/2. If I have the same base, you add the exponents. 1/2 plus 1/2 is 11. So that's really what's going on in the denominator, and the reason that we multiply by the square root of 11. Final answer, this is equivalent to the original, but it's cleaned up because I don't have a square root in the denominator. Perfectly fine to have the square root in the numerator. So on the second example, the square root of x, that's not a problem, but I want to get rid of the square root of 10. I can't simplify the square root of 10. There's no perfect square factors of 10. So I'm just going to start right away by multiplying by what I want to get rid of. What I do to the top, I have to do to the bottom. So now I'm multiplying by 1. I haven't changed the value of the fraction. The 2 stays out front. The 10 and the x are underneath the square root. And then in the denominator, the square root of 10 times the square root of 10 is the square root of 100, which is just 10. Now I can go ahead and clean up a few things. 2 divided by 10 is a fifth. So I could certainly write this as square root of 10x over 5. And now you might be thinking, well, can I say this is 2? No, the square root of 10 is like 3 point something. It's completely different than 10. So I cannot cancel those terms. The 10 is under the radical sign, the 5 is not. So this is your final answer with the denominator rationalized. Let's look at a slightly more complicated example. There's a couple of different ways to attack these problems. You could look at simplifying kind of the numerator and denominator individually, or you could combine this into one radical, which is what I'm going to do. So let's write this as the square root of 6x y to the 6 all over 21x squared y squared. And at this point, I'm going to clean up that inside a little bit. So let's see, okay, I have 2 x's in the denominator, 1 in the numerator. So 1x in the denominator should cancel with 1x in the numerator. Also, let's clean up that 6 over 21. So 3 goes into 6 twice. 3 goes into 21 7 times. 1x cancels in the numerator and the denominator. And if you look at my y terms, I've got 6 y's in the numerator, 2 y's in the denominator. 2 would cancel, leaving you with y to the 4th in the numerator. And now at this point, well, this would be the same as saying the square root of 2 times the square root of y to the 4th over the square root of 7x. The square root of y to the 4th, remember this is like y to the 4th to the 1/2. So 4 times 1/2 is 2. So let's move down here now. So I have the square root of 2 times the square root of y to the 4th, which is just y squared. In the denominator, I have the square root of 7x. So I've kind of cleaned up everything as far as I can go, except I haven't rationalized yet. So if I still have that radical sign in the denominator, I want to get rid of it. multiply by the square root of 7x. I have to multiply the top and the bottom. This fraction equals 1, so I'm not changing the value of anything. And lastly, if I'm multiplying fractions, go across the top, multiply across the bottom, and you've got a y squared out front under the radical sign. I'm going to take the 2 times the 7 times the x. So 2 7x, or excuse me, or maybe 14, 2 times 7 times x. And then in the denominator, if I have 7x, I'm taking the square root of that times the square root of 7x. This is really like 7x to the 1/2 times 7x to the 1/2. Half plus a half is 1, so your denominator is just 7x. That is your most simplified answer with your denominator rationalized. Again, make a note, I can't cancel out these x terms. One is under the square root, the other one is not. And I certainly can't say that 14 divided by 7 is 2. Because that's actually the square root of 14, not 14. Why don't you give this one a try on your own? So I don't know how you approach this problem. You may have just combined this all under one radical right away, so maybe you did something like this. I'm actually going to clean it up before combining it, and we should end in the same place if you went a different route. So the square root of 8 would be like the square root of 4 times the square root of 2, and then I have the square root of y to the 4th. In the denominator, I have the square root of 3, the square root of y to the 10th, and the square root of x. Now the square root of 4 is 2, which is why I factored that square root of 8. 4 is a perfect square, so I'd actually have 2 square root of 2. And the square root of y to the 4th would just be y squared, 4 times a half. In the denominator, I have the square root of 3. This would be y to the 10th to the 1/2, or 10 divided by 2, 10 times a half would be 5. And then the square root of x just stays since its exponent is smaller than the index of 2. Okay, so now let's rewrite this. I have, well, actually we can clean it up a little bit first. I have 2 y's in the top, 5 y's in the denominator. So 2 in the numerator would cancel with 2 in the denominator, which would leave you with 2 square root of 2. And in the denominator, I would have a y cubed now. And then I have a 3 and an x under the square root. So cancel those 2 y's. This is where you're at. So up to this point, I've kind of cleaned it up as far as I can go. Now one last step. Get rid of that square root in the denominator. So I want to get rid of the square root of 3x. That's what I want to multiply the numerator and denominator by. Then I'd have 2 square root of multiply 2 times 3x. It gives you 6x. In the denominator, you have y cubed. And then if I take the square root of 3x times the square root of 3x, the square root of 9x squared, that would just be 3x. Sorry for the pause there. Last thing I did was just rewrote it so the 3's out front in the denominator. And that's as far as you can go. Make a note, I certainly can't cancel these x's. 1 is under the square root, 1 isn't. So that's your final answer. Now, just a bonus note here. What if I have a cube root that I rationalize? So your homework, you're just rationalizing square roots. But if I want to rationalize with a cube root, you might think, well, okay, maybe I'd do this, same process. But now in the denominator, you actually have the cube root of 4. And the cube root of 4 doesn't simplify to an integer. So instead, maybe you guessed it, I'd actually want to multiply by this twice. So then in the numerator, I have the cube root of 2 times 2 is 4. I have an x up there. And then in the denominator, I've created a perfect cube. 2 times 2 times 2 is 8. So at this point, the cube root of 8 is 2. Because the cube root of 2 times the cube root of 2 times the cube root of 2 is just 2. So that's how you would rationalize a cube root.